Hello, this is Zulongye from Computer Engineering major, and now I will demonstrate the solution of homework 4 of Ece6303, question 1. Here we have the function y equals to gx into 0 minus x plus 1 minus 1. And here x is less than 0. 0 is less than x less than 1. 1 less than x less than 2. X is greater than 2. And we know because y is larger than minus 1 and less than 2. And we can get the distribution of function of y here is 0 when y is less than minus 1 and 1 when y is larger than 2. Here we can draw the picture of the function of gx. Gx. Here we have minus 1, 1, 2. Here, 2. Minus 1. Here's 1, 2. And we know when y equals to minus 1, and we can get the probability y equals to minus 1 equals to probability x is larger than 2, it equals to 1 minus fx2. And when y equals to 0, we know the probability y equals to 0 equals to the probability 0 less than x less than 1 equals to fx1 minus fx0. When y equals to 2, we know the probability equals to the probability x is less than 0. It equals to fx0. In the interval of minus 1 to 0, we have y equals to minus x plus 1. According to the formula, you will have this, and fx1 minus y divide the absolute value of minus 1 equals to fx1 minus y. Therefore, we will have the function of the density function fy. It equals to 1 minus fx2 here when y equals to minus 1. And second is fx1 minus y when y is larger than minus 1 and less than 0. And then fx1 minus fx0 and multiply impulse of y when y equals to 0. And then fx0 multiply the impulse of y minus 2 when y equals to 2. And other, the function will be 0. Also, in the interval minus to 0, we can calculate the distribution function fy. A equals to the probability y capital is less than y. And we can replace it with the function y equals to minus x plus 1. And we can get the probability of minus x plus 1 less than y. And we can get the probability x is larger than 1 minus y. It equals to 1 minus the probability x is less than 1 minus y. And it equals to 1 minus fx 1 minus y. Also, in the interval 0 to 2, we have the distribution function A equals to the probability y less than y, and the equals to the integration from minus infinity to y, and the density function. Then we can write down from minus infinity to minus 1, 0. Here, the integration of t equals to 0. It is t equals to minus 1. It is 1 minus fx2. Yeah, and then the integration from minus 1 to 0. Here is fx 1 minus t dt. And the value of t equals to 0. And it is fx1 minus fx0. And then we plus from 0 to y, and the value is 0 plus dt. And here we can get the value 1 minus fx0. And we can get the distribution function here. Distribution function fy equals to 0 when y is less than minus 1, and 1 minus fx 1 minus y when minus 1 is less than y and less than 0, and 1 minus fx0 when 0 is less than y and less than 2, and value 1 when y is larger than 2. And then we can draw the function into the picture. First, we have the x and its distribution function and its density function. Its density function is like this. And we know the distribution function is the integration of the density function, and it will be approaching to 1. Here we have x, and then we can draw the y function according to the calculation result above. And here at the point -1, we have an impulse. Its area is 1 minus fx2. And in the point of 0, it has an impulse function, and its area is fx1 minus fx0. At point 2, it also has an impulse. The area is fx1. And in the interval -1 to 0, it has a function like this. Okay, and then we can draw the distribution function. When y is less than -1, we have this 0 value. And then in the interval -1 to 0, we have the function like this. Here we get the value 1 minus fx2. And here we have the value 1 minus fx1. And in the interval of 0 to 2, the value equals to 1 minus fx0. And when y value is larger than 2, we can get the value is 1. So this is the picture of function distribution f y. That's all. Thank you.